The Sun, in overview. The Sun is the star at the center of our solar system, providing light and energy essential for life on Earth. It is a main sequence G-type star, primarily composed of hydrogen and helium, undergoing nuclear fusion in its core. The Sun has been a subject of scientific study, mythology, and religious significance across civilizations. 1. Etymology. The word sun comes from Old English sune, Proto-Germanic sunon, Latin sol, basis for terms like solar, and Greek helios, personified as a god in Greek mythology. 2. General characteristics. Type G2V, yellow dwarf, diameter about 1.39 million kilometers, about 109 times Earth's diameter. Mass about 1.989 times 10 to the 30 kilograms, which is about 99.8% of the solar system's total mass. Temperature, at its core, the sun is about 15 million Kelvin. At its surface, the photosphere, it's about 5,778 degrees Kelvin. Rotation period, at the equator it's about 25 days, and at the poles it's about 35 days, differential rotation. Age of the sun is about 4.6 billion years. The distance from the Earth of the sun is about 149.6 million kilometers, or 1 astronomical unit. 3. Composition. Hydrogen about 73% by mass, helium about 25%, heavier elements about 2%, including oxygen, carbon, neon, iron, and others. 4. Structure and fission. The sun consists of several layers. Internal layers. 1. Core, the hottest part, about 15 million Kelvin, site of nuclear fusion, hydrogen nuclei fuse into helium, releasing energy. 2. Radiative zone. Energy is transferred outward via radiation, can take thousands of years. 3. Convective zone. Heat is transported via convective currents. Hot gases rise, cool gases sink. B. Outer layers. 4. Photosphere. The visible surface. About 5,778 degrees Kelvin, emits sunlight. 5. Chromosphere, a thin layer visible during solar eclipses, appears as a reddish glow. 6. Corona, the outermost layer extending millions of kilometers into space, hotter than the surface, about 1 to 3 million degrees Kelvin. Source of solar wind is the corona. 5. Solar radiation and energy output. Luminosity of the sun is about 3.828 times 10 to the 26 watts. Energy generation, proton-proton chain reaction, fusion of hydrogen into helium is the energy generation. Electromagnetic spectrum emission, visible light is about 41%, infrared is about 50%, and ultraviolet is about 9%, which is what causes sunburn and ionizes the Earth's upper atmosphere. 6. Magnetic activity and solar phenomena. The sun's magnetic field produces solar activity cycles, which last about 11 years, leading to A. Sunspots, dark spots on the photosphere caused by magnetic field interference. B. Solar flares, explosive releases of energy emitting X-rays and charged particles. C. Coronal mass ejections, CMEs. Late eruptions of plasma that can disrupt Earth's magnetosphere, cause auroras, impact satellites. D. Solar wind, a continuous stream of charged particles flowing from the corona. 7. Life phases of the sun. The sun is a main sequence star but will undergo future changes. 1. Formation. About 4.6 billion years ago, collapsed from a molecular cloud. 2. Main sequence. About 10 billion years total. Burns hydrogen into helium. 3. Red giant, about 5 billion years from now, expands beyond Earth's orbit and core contracts, helium fusion begins. 4. Planetary nebula, about 7 billion years from now, outer layers are ejected, leaves behind a white dwarf. 5. White dwarf, about 8 billion years from now, a cooling remnant, eventually becomes a black dwarf, hypothetically, but takes trillions of years. 8. Location and motion. Position in the Milky Way, located in the Orion Arm about 26,500 light-years from the galactic center. Motion orbits the Milky Way at about 828,000 kilometers per hour, completes one orbit in about 225 through 250 million years. 9. Observational history. A. Ancient observations. Egyptians worshipped Ra, the sun god. Greeks and Romans personified the sun as Helios, or Sol. Mayan and Aztec cultures built sun temples and calendars. B. Scientific advancements. Heliocentric model, 1543 of Copernicus. Sun at the center of the solar system. Galileo in 1610 used a telescope to observe sunspots. 19th through 20th century, spectroscopy confirmed hydrogen and helium composition. Discovery of solar cycles and magnetic fields. 10. Observation by the naked eye. Sunrise and sunset colors due to Rayleigh scattering. Solar eclipses, moon blocks the sun, total, partial, and annular. Solar observation risks. Direct viewing can cause eye damage. Safe observation methods that pinhole cameras, solar filters, telescopes with proper shielding. 11. Religious and cultural aspects. Egyptian mythology, Ra, the sun god, creator of life. Hinduism, Surya, the solar deity worshipped in rituals. Greek and Roman mythology, Helios, Greek, Sol, Roman, personified the sun. Aztec religion, Huitzilopochtli is a sun god central to human sacrifices. Christian symbolism, the sun is metaphorically linked to divine light and to Jesus Christ. Modern solar festivals, winter solstice celebrations, Yule, Christmas, Dongxi Festival, summer solstice festivals, midsummer Stonehenge gatherings. Conclusion. The sun is the foundation of life on Earth, governing climate, weather, and biological cycles. It has shaped human science, mythology, and religion for millennia. Advances in solar physics, space exploration, and astrophysics continue to reveal its mysteries and its role in the cosmos.